The ability for APC software to reduce process variability, product giveaway, and optimize against process constraints is well understood. Often this optimization has been accomplished in silos from other production stakeholders. Today, especially in the volatile energy future in the downstream refining and chemicals industry, the benefits of steady operation will be managed in real time against the gap existing between plan versus actual. While production optimization is not new, the ability to dynamically coordinate multiple process units in closed loop and automatically adjusting APCs is a market driver. Production optimization software is easily deployed and maintained by APC engineers and is often a logical extension of the APC's workload. I'm Peter Reynolds, Senior Analyst, and this is the Digital Transformation Viewpoints podcast brought to you by ARC Advisory Group. In each episode, we'll ask big questions of how industry is adopting emerging technologies and practices for sustainable manufacturing, from better operational and engineering processes to blockchain. Today, however, our focus is accelerating process optimization during the volatile energy markets. Here with me today is Christophe Romatier, Senior Director, Product Management, and Jaideep Bhattacharya, Global Product Manager, APC, Optimization, and Process Control at Honeywell. So plant optimization is certainly not new. So in fact, back in I think it was the 90s, plants began to tap into the potential of the computer era by running a commercialized multivariable control over real-time industrial control systems, right? So here we are 30 years later. So why do you think there are still so many untapped opportunities in the plant optimization space? Let's start with you, Christophe.
Well, Peter, what we've been seeing past few years, and especially the past year itself with COVID and the situation globally, is a lot of volatility in the market. So with a lot of feed changes, a lot of product target changes, the economics around energy that are changing faster and faster, operating companies really need to be agile. They need to respond to those changes very quickly, and that's really hard to do. What we've observed is that most oil companies are still quite siloed organizationally, and that leads to a lot of inefficiencies that frankly leaves money on the table.
Right.
There's different objectives in different departments, the different scale all these departments act. And what, by our estimate, is actually leaving around $2 to $5 million per year of untapped potential or losses on the table.
Interesting. Okay. So it's clearly, a mature area. The technology is certainly robust. Is there something about how the users have been applying the technology, or has there been resistance to change, or is really the optimization problem, just too complex to solve? Like why haven't we solved this before?
What we see today in most companies is really that the systems are as disconnected as organizations. Meaning you have a separate planning department that's separate from operations, that's separate from process technology, and the systems that these different departments use are also different and don't typically interact or only interact with humans in the middle. And so that's leading to a lot of this inefficiency. There's nothing that really orchestrates the plant between the planner and the valve. And so as the speed of change required in the operation goes up, it really brings out the inefficiencies that these disconnected systems are causing. And as refineries are getting more and more complex, right, with bigger refineries, more refining petrochemicals integration, these super complex facilities have a hard time staying on top of all the changes that are required. And so what this leads to is the planning department can come up with a plan, but it may be very difficult to assess feasibility. And that leads to a lot of imbalances between the production and the inventories.
So it seems like the scope of optimization maybe has changed a little bit. And, certainly Honeywell has had a solution, an optimization solution for, quite a long time. So Honeywell has a new, or you've made some changes and enhancements to your plant-wide optimization solution. So what can you tell us about what's unique about this solution? Jaideep, maybe we can move over to you.
Hey, hi Peter. Good morning. As Christophe rightly mentioned about the problem statement, when we look at an end-to-end optimization scope, the challenges and the potential opportunities at hand, Let me try to explain what we as Honeywell, who have been in the APC space for more than 25 years now, are doing uniquely to solve this using our plant-wide optimizer solution. Essentially, plant-wide optimizer is a multi-layer solution which uses a highly abstracted yield/property model at the top, very similar to a flowsheet type model used by the planner that understands the overall end-to-end dynamics. However, the solution acquires the unit level operating constraints through the APCs and hence delivers a combined multi-scale end-to-end optimization solution in real time. Now, structurally, it is a 1 to n MPC cascade, one primary APC cascading on multiple secondary MPCs. The primary MPC employs a dynamic model which can be at a user's discretion a high abstraction level or a core scale model as we call it. The slave MPCs also employ a dynamic model. However, this is a low abstraction level or a fine scale regular APC models. And if we employ the secondary MPCs at each process unit, then the master MPC can solve the plant-wide production control problem dynamically and in closed loop. Okay, so essentially three things that makes this solution solve the end-to-end optimization problem uniquely. The first is around the speed and agility, wherein the solution optimizes every minute by using dynamic models, resulting in real-time feedback and precise control. Secondly, it can handle a comprehensive scope wherein the solution manages inventory and delivers optimal material routing across the enterprise by integrating process optimization with planning and blend operations. And while we do 1 and 2, plant-wide optimizer also ensures that the solution is feasible, meaning the results are always implemented in real time. And this is achieved using our patented technology of proxy limits and key decision variables through a two-way collaborative communication between the overarching primary controller and the underlying secondary controllers or the APCs on the units. So essentially, Peter, it is Honeywell's patented techniques which dynamically optimizes across the scope of the whole enterprise, always ensures a feasible solution, driving enterprise decision making in real time. And that is our secret sauce.
That's interesting. So it seems like perhaps the way it used to be done is there was a lot of local optimization taking place. So now it seems like with your solution, things are more plant-wide focused. It's no longer just about reducing variability. So it seems like there's more of a business approach to your APC solution. So can you give me an example of some customer use cases that you've solved using the plant-wide optimizer?
Yeah, absolutely, Peter. So on customer use cases, I will talk of top 3 customer success examples based on our project experiences. Now, these are projects which have been implemented at customer's place or under implementation. I will start with a major oil refinery use case where the customer wanted the solution to enable enterprise-wide gasoline and diesel pool optimization for low sulfur diesel. The project ensured a guaranteed product delivery through optimal integration of process and blend operations, and also delivering final product specs while ensuring most economic unit feed allocations across the units, and also maintaining the unit parameters. The benefits from the project are expected to be around $2 million per year. Okay, so the second use case is from a gas processing facility where the plant had both offshore and onshore operations. And the key objectives for this project was around maximizing overall profitability of production across the entire facility in real time. And the implemented solution ensured that capacity utilization across all offshore and onshore assets are maximized with optimized use of process facilities by reallocating production to meet changing customer needs. The typical benefits for this customer was in terms of increase in overall gas export to the tune of 0.5 to 1%. I have a third use case that I would like to mention here.
Okay.
Is about a gas processing NGL facility where the customer wanted to optimally distribute the gas feed across multiple parallel NGL trains. And the solution implemented using plant-wide optimizer ensured optimum feed gas flow and distribution across the units, resulting in recovery maximization. The other key objective implemented solution successfully delivered was around minimization of energy consumptions based on condensate RVP, while maintaining the overall production requirements. And the benefits this customer got from the solution is around $3 million per year. Okay, so as you see, Peter, the solution finds a place across industry verticals and their typical use cases, and it can solve any wide area optimization problem, which would require integration among various operational and business functions quite effectively, delivering millions of guaranteed benefits yearly to customers.
Interesting. So with that scope in mind, and certainly I think the use cases that you mentioned are certainly compelling, what do you recommend for customers? How should they get started on an optimization journey?
Okay, so my final words will be on how to make a start to an end-to-end optimization journey for a customer. Now, it can start with an opportunity assessment exercise. Now, we as Honeywell provide two types of assessment. A giveaway study, which is quick and should be sufficient to provide a sense of the potential and the feasibility based on the use case at hand. Estimation requires some amount of data, but not much. And here, no detailed simulation, etc., are required. Second is a more detailed benefit analysis with day-by-day data modeling, which is more accurate assessment of potential, but requires a significant time and effort and a good amount of data. So I would suggest that enterprises can reach out to Honeywell, and we will be happy to help them make that start.
So we're coming to the close of the podcast. Do either of you have any final thoughts for the audience today? Perhaps something that you're thinking about in the future? Can you talk just quickly about that?
Yep. As my last thoughts for today's podcast, I would like to talk about the future development work planned for the solution. We are planning to expand the plant-wide optimizer solution to address greater use cases at an enterprise level to deliver an enterprise business plan in real time, making plant-wide optimizer a true enterprise level optimization solution for a larger part of the supply chain. For example, a combination of multiple refineries and fuel crude depots, including interplant transfers in terms of order and material transfer, all key requirements for operationalizing an enterprise-wide business plan.
Well, Christophe and Jaideep, thanks very much for being with us today.
Thank you, Peter. Great talking
Thanks, Peter.
today.
Well, that's all we have time for today. Thanks to Christophe Romatier, Senior Director, Product Management, and Jaideep Bhattacharya, Global Product Manager, APC and Optimization and Process Control with Honeywell. For more information and insights on this topic or to learn best practices to accelerate transformation, please visit the ARC Advisory Group website at www.arcweb.com. Please do subscribe to this podcast so that you don't miss an episode. And while you're there, leave us a review. In the meantime, from Peter Reynolds, thank you for listening and goodbye.